Hello, this is BeMathHero, and today I am going to expand the binomial theorem, that is prove the binomial theorem through the mathematical induction. And as we know that we have got the given formula for the binomial theorem, that is a plus x power n is equals to, it is nc0 a power n plus nc1 a power n minus 1 and x plus nc2, it is a power n minus 2 plus x square going up to ncn x power n. So we're going to prove this formula by using mathematical induction. So before proving that, we have got, let us write down the proof for this. We have got a proof. So let us suppose that n be a positive integer. So we have supposed n be a positive integer. So after supposing n to be a positive integer, we'll write down as n equals to 1. When n equals to 1, what is the value? Then in the left hand side, when n equals to, it will be a plus x power 1 is equals to, it will be a plus x, while in the right hand side it will be r is equals to, let me write 1 c0 a power 1 plus 1 c1 a power 0 x. Similar, if you go to others, it will be valid, so you won't write that is equals to, it will be how much? It will be equal to a plus x. As y, as we can see that for 1 c0 it is equal to 1, while for 1 c1 it will be equal to 1. So we can, in place of that, we can write down a plus x only. So here we can see that we can find out that LHS is equal to, we have got RHS. So that's why we can say that this theorem holds true for n equals to 1. Here we have completed the basic steps of mathematical induction, that is, we have to keep n equals to 1, and if it's true, then we'll go ahead. Now we'll go with the induction step. So here we'll suppose that, suppose it is true for n equals to k. Okay, then we suppose that. That means if n equals to k, then we can write a plus x power k is equals to, in place of k we'll write down k c0, there was nc0, we'll write down k c0 a power k plus k c1 a power k minus 1 x. Similarly, we'll go up to the k ck, that, and x power k. So after writing this, so we still have to show it true for. Next step is to show true for n equals to k plus 1. Now we'll show for k plus 1. So that's why in the left hand side here we'll have got a plus x power k plus 1, it will be equal to a plus x into a plus x power k. I have written just opposite, so understand it. Now in place of a plus x power k, we can write down the given value, that is kc0 a power k plus, we can write down kc1 a power k minus 1 x power 1 plus kc2 a power k minus 2 x. Now similarly to others it will be, x square, to others it will be equal to kck and x power k. So you can write down this. Now we can say that while you multiply this, I will multiply this and this, so we can write down here kc0 a power k plus 1, it will be like this. That means while you multiply this and this, it will be kc0 a power k plus 1. Similarly, while you multiply this and this, and we'll multiply a with this value, it will be equal to kc1 a k k and x square. So we'll go like that. It will go like that. Then if you multiply the last value with a, it will be k c k a x square. Similarly, if you multiply with x, it will be equal to other value. So while we do at yeah, at this place this will remain same, while we have got common, that is kc1 and kc0 have got a common factor, that is a power k x, right? While you multiply this, you can multiply in your own course, while kc2 and the kc1 have got a common of a power k minus 1 x square, plus while you go to others, for kck and kck minus 1, you can look at the what do we call that as this and this number, then they have got some relation, that is k minus 1. So you can do a case also, a power a x power k, plus here will be k ck, it will be x power k plus 1. So if we go on continuing from here, then what will we get is that we will find out that this one, here we have got k plus 1 c0, k plus 1 will be here, as k c0 will be equal to k plus 1 c0. Similarly, in second one, here will be k plus 1 c1 a power kx, as we can tell k cr plus kcr minus 1 will be equal to k plus 1 cr. So you can write down that here. Similar for other, it will be same, and in the last it will be a k plus 1 ck plus 1 instead of k ck x power k plus 1. So we'll write down here as k plus 1 ck plus 1 will be equal to k ck. So yeah, as you can see that instead of k we are getting k plus 1 in each and every factor. So we can say that it is proved by mathematical induction. Therefore, as it is true for n equals to k plus 1, so proved by mathematical induction. Right then, in this way you will prove the binomial expansion using mathematical induction.